Flow profiling sounds cool, and coincidentally, it also is very cool. But unless you're Georg Simon Ohm himself, it may not be immediately intuitive what flow profiling actually means. For instance, why does flow profiling affect pressure? And if it does, then what even is pressure profiling, and why does it seem like they're kind of the same thing? And as much as any of us might love cool knobs and gauges, what does any of that have to do with making good coffee? Well, thankfully, flow profiling is actually pretty simple, and you don't need to be a renowned 19th century German mathematician to understand it. Today, I'll be covering the basic principles behind flow profiling, what you can do with it, and how it can help you pull better shots of espresso. To understand flow profiling and pressure profiling and why they seem to be the same thing, it helps to first understand how they kind of are the same thing. Pressure and flow aren't two different levers you can control independently. They're fundamentally connected. Their relationship can be described by the simple equation flow rate equals delta pressure divided by resistance, which is just a fluid analogy for Ohm's law for electricity. That's the last time I'm going to mention electricity, because if invisible electric pressure is more intuitive to you than water, you're weird, and I don't know if I can help you. When it comes to espresso, each of these variables is thankfully a bit more tactile. Flow rate is the volume of liquid, in this case espresso, coming out of our portafilter per second. Delta pressure is the difference between atmospheric pressure, which is usually around 1 bar, and the pressure inside our machine. In a by-the-book shot of espresso, that would peak at 9 bar, for instance. Resistance is our puck of coffee, with more or finer ground coffee providing more resistance and less or coarser coffee providing less. If you've dialed in before, you're already familiar with this part. A standard espresso machine without a flow control system produces a constant flow rate of water when there's no puck in the way. Once we pop in a portafilter and add resistance with our puck, both flow rate and pressure are then entirely dependent on the resistance provided by the puck. This is why grind size is so important in espresso, and it also means that once we've started the shot, there's nothing we can do to change the equation. We just get to sit, watch, and decide when we want to stop it. That all changes when you stick a little valve between the machine's pump and the puck, and that's all that the majority of flow control machines are doing. With this little valve, you now have the ability to restrict the max flow rate of the machine on the fly. Now, because we can control flow rate, and because pressure is simply determined by flow rate times resistance, we can now also control pressure. This is partly why flow profiling and pressure profiling are used interchangeably. They're essentially just two different ways of engaging with the same process. The specific control mechanism may look different from one machine to the next, but the important thing is that with this little lever or paddle or whatever, you can now decide both how much pressure and how much flow you want during any part of the shot. Opening the valve allows for more flow, which also increases the maximum pressure. Restricting the valve limits the flow, which reduces the pressure. Neat. Hopefully this already sounds cool and exciting. I mean, if it didn't, you probably wouldn't still be watching this anyway. But now that we've gotten the how out of the way, we have to start to grapple with the why. And with flow profiling, there's a few whys, but we'll start with the first one that comes up right at the beginning of your shot, pre-infusion. You're probably already familiar with the ways that pre-infusion can help you get more consistent shots. Flow profiling is like pre-infusion on steroids. Not only can you decide the flow rate that you want to start at, but you can also slowly ramp it to your max target flow rate to get even more consistent and smooth results. Flow control also comes in handy at the end of your shot. As you continue to pull your shot, more and more coffee stuff gets pulled out of the grounds, and the resistance of the puck naturally decreases, allowing for an increased max flow rate. Using flow profiling, you can reduce the max flow rate of the machine, either to reduce the rate of extraction or to hit a target recipe. All in all, this direct control over your machine's flow rate can help you achieve greater consistency in your shots of espresso, or help you experiment with different flow profiling curves and recipes. It also makes it really easy to adjust down to a lower pressure for something like a turbo shot. Flow profiling is a powerful tool when it comes to pulling great shots of espresso, and it's also more accessible than ever. I hope this video helped you better understand how it works and also why it's handy. For more espresso experiments, tap subscribe, and as always, thanks for watching.